the time was to do 2 lanes at a time. Put temporary barrier on, demo 2 bridges at a time, and then Bobby, myself, and my boss, Paul Malloy, sat down and said, if we demo between 2 structural steel beams, what's this piece of concrete gonna do? We already know it's junk. Is it gonna fail on us? Are we gonna end up with a catastrophe because of it from one weekend to the next weekend?
Yeah.
So then we started the mindset of doing the whole bridge width to width. And at that point, traffic came into the meeting and said, whoa, time out. Where are you putting everybody?
Yeah.
Well, that's not my problem, that's your problem. You tell me where, I need to take the bridge out.
Yeah.
So that's when this whole concept of the movable barrier came into play. We use it on a daily basis on the Southeast Expressway.
Yeah, the zip lane.
The zipper lane.
Yeah.
So we went ahead and did the same thing. Okay, what do we need? Where can we cross people over? So, here's the last bridge, but because of elevation changes and curves, we couldn't get the crossover all in place until Stoneham. We're about a mile north of our last bridge.
Yeah.
Before we could get a flat enough area for high-speed traffic to transfer over.
Yeah. I remember thinking that the first time I had to cross over, going, geez, quite a distance away from the actual work you crossed over. Yeah.
And then again, certain stuff comes with that. Lighting, we had to do all kinds of overhead lighting in this area because it's a change of lanes, it's a shift of lanes, it's got to be at a higher risk type of thing versus the normal overhead lighting on the interstate highway.
Yeah.
So then we go to the south side, and it's, not that far behind the last bridge, but it's part of a curve system. There's on and off ramps, so we had to shut on and off ramps and switch you over, in the Medford, almost into the Somerville town line, to get people back over. So then with that in hand, we go from there. It started. Bobby can show you a quick video on basically it's a quick overview of everything that happened to us. Obviously the deck failures back in August, why we started, and then it goes through and it tells you all the critical paths, and then we can get into it a little bit more refined from there. Please set.
When's it doing that? Add the disc in there, and
Didn't you have it up already?
I did have it up.
Pull it off, put it back in.
I had to do that to my phone because the battery wasn't seated right.
I'll get into this a little bit, Bobby, with the weekend work. What basically we determined was there's 10 bridges, 8 bridges, 10 bridges out there from 5 northbound, 5 southbound. Okay? South to north, Route 16, over the river, Riverside Ave, eastbound on the Rotary at Salem Street, westbound on the Rotary, and then the Valley, Webster Street, then Valley Street.
Oh, was it Webster? Webster the crossing.
The crossing was on Webster.
Yeah, okay.
There we go.
So is that all of the bridges right there?
That's all of the bridges.
Okay.
And you got that running?
Yep.
All right.
Okay. Good.
historic event was unfolding this summer of 2011. For 10 summer weekends, the most aggressive accelerated bridge construction project in the United States took place along the major artery of Interstate 93 leading into Boston.
Hear it okay?
Yes.
Massachusetts had been proactively working to replace their rapidly deteriorating infrastructure. However, the pressure to speed up the process was increased after a major bridge collapse in 2010. The Massachusetts Department of Transportation was charged with creating a plan to replace the failing bridges at a speed and volume never attempted before. The one caveat was the plan must have minimal impact on the 200,000 commuters who travel this roadway each day. The I-93 Fast 14 idea was born. 14 bridges, 12 weekends, 55 hours each week to tear down, rebuild, and reopen for traffic. Mass DOT developed the plan, put it out to bid, and awarded the design-build project within 5 months to well-respected union contractor J.F. White, who would partner with Keywood Construction in a joint venture.
This project really fell into their swing zone, which is a heck of an undertaking, and no other contractor or no other job in this country, I believe, has ever attempted that.
J.F. White, who for 90 years has relied on the skilled tradesmen of the Massachusetts building and construction trades, now needed them more than ever. The schedule would be intense. Preparation, coordination, and cooperation would be the key to success for this project.
Management and labor, we work together. Here's a project that was supposed to be 14 bridges in 12 weekends, but we did 14 bridges in 10 weekends. We accomplished a feat that's never been done in the country, and that's what we did.
They sure did. Everyone knew the job would be 24/7. In the middle of each week, crews performed the jacking, underpinning, and coping needed to stabilize the bridge for demolition. Prefabricated modular superstructure panels made up of 2 steel I-beams and a concrete deck were assembled off-site at a plant in New Jersey and trucked to a staging area set up in Wilmington, Mass. This first-of-its-kind project would begin on the weekend of June 3rd. At 5 p.m., laborers began securing the roads in the area near the bridge. They closed the local roads beneath the bridge by setting up signs, fencing, and placing concrete barriers to block the traffic. Simultaneously, above deck on the highway, another crew of laborers were placing the fluorescent cones and barrels in an exacting pattern to create the new lanes that will assist in the diversion of traffic. At 8 p.m., an impressive convoy of tractor-trailers carrying the prefabricated bridge panels began the carefully choreographed operation. By 10 p.m., Testacorp, a longtime signatory contractor, had their demolition team in place and was ready to begin the teardown that would last until dawn. The nighttime world of construction began to unfold as the light towers revealed the monstrous hydraulic excavators pounding into the roadway deck. Under the bridge, laborers worked rapidly with high-pressure hoses spraying the foam dust to a minimum.
You know what I thought for.
A crew of laborers cut away the steel beams still left on the structure so the large grapplers could pull them free. Giant mechanical shears easily sliced the old steel beams into manageable sizes for transportation off the site. As the night wore on, crews worked methodically to load debris onto trucks for transport out of the area.
You're right.
By first light Saturday morning, the entire bridge was gone. The structural team would now begin preparing the precast piers and bearing pads to receive the superstructure panels as they moved onto the site. They began the painstaking process of carefully hoisting the massive panels into place. Crews guided the panels onto the precast piers over the rubberized bearing pads, which will aid the dimensional integrity of the bridge. An average of 18 panels completed each bridge surface. The entire project utilized 252 prefabricated panels weighing just under 11,000 tons. Laborers now moved onto the bridge with materials and did the prep work necessary before the wooden closure forms were put into place. The labor-intensive task of installing and tying off the rebar between each panel began. Each 32-inch closure joint would eventually be filled with a specialized concrete mix designed specifically for this project. The work continues well into the evening. At 3 a.m., it's time for the accomplished team of laborers to take the stage. As the concrete trucks move in, this team awaits anxiously to begin the pour. The go-ahead was given, and the laborers expertly sprung into action. Throughout the rest of the early morning hours and into Sunday, laborers worked quickly and proficiently, pouring, vibrating, and finishing the 32-inch closure joints between each panel. This is a crucial point in the process, for the concrete will reach 2,000 psi within 4 hours. By morning, it will reach the desired 6,000 to 7,000 psi. On Sunday, the concrete is set and inspected by Mass DOT officials, and the bridge declared ready. Laborers then erected temporary barriers along the sides of the new bridge deck. The bridge is complete and ready for traffic well before the 5 a.m. deadline. As expected, each one of the 14 bridges was demolished, removed, and rebuilt hours ahead of schedule and well within the $98.1 million budget. Using conventional construction techniques, this job would have taken 4 to 5 years at a cost of $190 million.
The Mass Laborers District Council worked closely with Home Local, Laborers Local 22, and all of its affiliated locals throughout the Commonwealth to make sure that the contractor had the appropriate resources they needed to complete the job on time and on budget. And I think we delivered a quality product to the owners of this project, which in this case is the Commonwealth of Massachusetts taxpayers.
Federal Highway Administrator Victor Mendez and 160 DOT officials from across the United States witnessed this impressive feat firsthand.
This is an impressive, really impressive project. You have a lot of laborers, so it's a credit and a tribute to really the investments that we're making in transportation, the fact that we are creating jobs today, and in the long term we're investing in our infrastructure.
The laborers of Local 22 and the surrounding Lyona locals are proud to be a part of the collaborative effort bringing new and efficient methods of construction to the public. After all, as loyal union members and proud Americans, we all benefit from innovation, cooperation, and the opportunity to work together for a common goal.
The laborers build America.
Laborers build America.
We build America. Laborers build America. Laborers build America. I build America. Laborers build America.
Laborers build America.
That's pretty impressive. The spacing between all your modular units there, is that just what dictated that? Was it just curious? I mean, you had the modular units built. The width of them and the length of them.
Two things became the critical path on that. We the day we met with structural engineers, both hired by MassDOT, which CME Engineering out of Connecticut was our correspondents from MassDOT on the bridge portion, and Joe Gill Association was part of the design team, build team with Keywood and White. We had existing pedestals out there that the old bridge sat on. Now we needed to determine locations of those pedestals and what are in conflict with the new locations. And also we went to a smaller beam size in a lot of locations because we were looking for the vertical clearance underneath to today's standard specifications versus 1959 when it was built. So we needed to raise that number on a lot of bridges, and we were successful in 9 out of the 10 to do that.
Okay.
Either by changing a little bit of the vertical elevation out on the throughway itself, or by going to a smaller beam. When we went to a smaller beam, the spacing became narrower. From, I think it was 9 something,
Yeah.
center to center on the original, and then we're down to 8.3 or 8.4 with the new design. So we end up adding a beam to most bridges.
Yeah.
Over the river, we end up adding 2 beams and a whole additional section. We're one section wider over the river because the spans were longer, and we were having a problem with weight, picking weight for cranes, because we couldn't get a crane in the river on a barge because it was too shallow.
Yeah.
So we had to have 2 cranes from each end. So the weight was a big concern to us. We were over the 150 factor that we use for safety,
Okay.
and we couldn't get a crane large enough. And as it was, that crane came in on 8 tractor trailers, and it was put together by 2 other cranes. That's how big that crane was.
Wow.
So, long story short, yes, it did become critical. The spacing became critical. Everybody's impressed with Testa, and they, they came in at 10 o'clock and they were gone by 7 o'clock. Fantastic. But he left stuff. People don't understand that. He didn't take the pier cap and columns
Yeah.
that we had already repaired, and he didn't damage any of the new pedestals that we put out there. We temporary shored,
As well as the abutments.
right, X amount of each, anything that was in conflict, we had to shore the existing beam so we could work around it on the pedestals to create new pedestals, but we also had to keep the bridge alive for weeks, holding the 200,000 cars.
Right, right.
So, that a lot of stuff became critical. So as we get into this theory, we've got 5 bridges northbound, 5 bridges southbound. We sat down as a team, a MassDOT team, and said, okay, if we do all these bridges in successive weekends, how do we handle this to the point that non-destructive to the city of Medford? Because obviously we're going to cut the city of Medford in half, East Medford to West Medford.
Right.
So we determined that if they were working on Bridge 1, other roadways for detours and maintenance of local traffic had to be open. So we spelled that out in the contract to them, that you couldn't work on simultaneous bridges at certain times. We needed to have that as a crossroad as you're working on this one down here.
Okay.
So sitting with the local police, the local fire, which by the end we couldn't please the local fire. What happened was we ended up doing a detail watch through the weekends, where they would send ambulance and pumper trucks on the other side on our dollar, and maintain the level of safety that they wanted to maintain on the other side, on the westerly side or the easterly side, based on where we were working up and down the corridor.
Sure.
Because the detour route was too far and too intense for them to get an ambulance from east to west. So
Right.
we just housed them on the other side of the bridge. We paid the cost to keep them on call, and
Yeah.
and it worked out. It ended up being less than $100,000, $110,000. It was short money in the scope of the job to
Absolutely.
keep, fire and ambulance service and everybody safe.
Yep.
So that's where we came up with 10 bridges. Now we said, okay, we gave them to the contractor. This was the contractor's proposal back to us, that we would do these bridges in this succession, starting on the northbound side. So Riverside Ave was our first bridge. No ramps associated with it. Kind of a little street below. It's only short distance. It's not that wide of a bridge. It's not, nothing. No major skews. It's a pretty square bridge. Let's learn here.
Yeah.
So that was our first undertaking. But as everybody forgot, there was April to the first weekend in June that we needed to do all the concrete repairs for the existing abutments and piers, create our new pedestals for our elevations for the new structures coming in, make sure our new structures we're actually going to get here, which got to be quite comical because New York DOT and the police in New York weren't happy with our overweight permits for our trucking teams. They were pulling all the stuff up here, so they would pull them over and detain them. Or you can't ride on this road between 7 a.m. and 3 p.m. So you got to park on the side of the road. It got to the point where we needed the state police to step in and kind of coordinate with New York DOT and New York police to say, this is a critical path. We really need those pieces that you have. And on the side of the road in New York, we need it on the Mass Turnpike.
Yeah.
We couldn't go through Connecticut either because they wouldn't.
Their bridges weren't weighted enough to handle what we were going to put over them for weights.
Wow. That's why we had to
There
go
was
up
no other manufacturer or subcontractor that could.
Locally, no. Nobody wanted to take on the endeavor because it was too large. They were in Jersey Precast from New Jersey said that they'd take it on. They do a lot of work with Kiewit nationally, so they said they'd take it on.
And then Structel from Maryland.
Structel, did all the steel work. They built all the beams. They sent them from Maryland over to New Jersey.
Who was that again? I'm sorry.
Structel.
Structel. Thank you.
You're welcome.
So how long was the whole duration for them to design and build all those precasts?
We gave them a contract in February, and the first bridge weekend was the first weekend of June.
It's pretty fast.
There was outside critical paths, there was inside critical paths, and then there was the 55-hour critical path. Everybody kept saying, "Oh, you got 55 hours."
No.
We might never even got to 55 hours if the outside, which was fabrication,
Not there.
If the
Wasn't
critical
there.
paths weren't met, so.
and also what they needed to do to the existing structure that we were keeping below. So there was a lot of stuff that had to go on prior to the weekend.
Yeah.
That was critical path. And everybody kept saying, "Oh, 55 hours critical path." Well, as I explained to Brian, we rented an old Catholic school. The design build team, through the contract, needed to provide MassDOT X amount of square footage of space for engineering, design, so forth. They couldn't find anything. They either could find a piece of property that had 30,000 square feet or a piece of property that had 2,000 square feet. There was no 5 to 8 that we were looking for both teams, because we put right in the contract that they needed to be in the same office building as us, so we could just walk back and forth.
Yeah.
It didn't happen. They couldn't find anything local. They were starting to look at other cities and towns around Medford, and the mayor stepped in and said, "I want you in Medford. This is happening in Medford. I want you in Medford. I want to be involved in it," which he was on a daily basis, weekly basis. So he said, "How about the Catholic school that closed a year ago?" So we rented the local Catholic school for a year and a half. We were on the top floor, they were on the bottom floor. And, the design, that's how it started.
And who was that on the bottom floor again?
White Kiewit,
Oh, okay.
the design build team.
Got it.
What was that Catholic school's name?
St. Francis of Assisi.
Is that the one right
Right on the fells, right?
next?
And it was on the job.
Yeah, pretty much. Yeah.
It worked out perfect. I mean, we could walk to the Valley Street Bridge from it, and it was in our detour route, because the Fellsway was part of our detour route. It just worked out.
Yeah, it's a good spot. Yeah.
There was plenty of room too, because you had the entire floor, so they could have conferences and those large tables and stuff like that.
We had a weekly conference between 40 and 80 people during the design build, and then during the build out itself, we always had a meeting Monday morning to go over everything that happened last weekend, and then we would meet again on Wednesday to start planning, for the upcoming weekend.
Yeah.
It was quite intense at times. We, Bobby and I, we had the luxury of utilizing Brian, who does the same thing I do in the area, and all the other area engineers through the weekend process, to come in and kind of be our eyes and ears when we needed to actually get some time off, which, you can't work 55 hours.
Right.
We tried a couple of weekends, but it didn't quite work out that well.
I was lucky too, because I worked 3 weekends out of all the weekends, and I got to see different phases of the project. The only thing I didn't get to see was the demo, so I got to see something different every time.
And that was what was good, because we were switching the guys around so they could see everything too.
Yeah.
Because we know going forward there's going to be more and more of this.
Right, get on.
So let's get all the guys that are here. I mean, I'm the old timer amongst the area engineers at 53.
Yeah.
So, let's get the younger guys, thinking. I mean,
Yeah.
Mark came in here,
Yeah.
and did a lot of work for us on the weekends on back bridges that, we were kind of forgot about, but they needed membrane and waterproofing. They need barriers to be installed on them. They
Yeah.
needed to be paved. Mark led a team of guys back there, and then Brian would come in on a Sunday afternoon a couple times, and I would throw everything on his plate and say, okay, button this thing up. I'm going home. I haven't been home in 2 days, And Brian would button it up to get it open for 5 a.m. in the morning.
Yeah.
So the collaborative effort amongst Mass DOT people was outstanding. Bobby would go home for 4 or 5 hours, and he probably felt like he was only just got home because he lives out west a little ways. So he had probably an hour ride in each direction, and I'd be calling him as soon as he got home and said, when are you coming back? Things like that, or as the call would come in, he'd say, don't worry about it, I'm right on route to bottom end of Route 2, I'll be there in 15 minutes, It was just a great bunch of guys, but the stress level at times was crazy.
Yeah.
It mentions in there that we got into a concrete, a specialty concrete for the closure pours. It was one of our critical paths from day one. We sat through the winter time designing this concrete mix that would get to those compressive strengths so we could open it up in the morning. But as we got to those compressive strengths, other things happened. We had too many air voids. We had too many, shrinkage cracks. We,
Didn't achieve strength.
Didn't achieve strength because it was,
Was Chicago testing and CTL, Chicago Testing Lab. So basically they concocted this chemistry set.
They took the materials from here, put them in 55-gallon drums, took them back to Chicago, and designed off of our specifications that we designed during the weekend, designed something that we could be happy with, and then sent it to Boston Sand and Gravel and said, make this. Well, it's never been done before. So there was testing periods, They talk about getting to 2,000 PSI in a couple of hours, We were achieving 4, 5, 6, 7,000 PSI in less than 4 hours with this mix.
I saw some video clip showing the DOT engineer doing the on-site testing.
We had 2 on-site testing labs. The young gentleman that worked for Bobby and I did so many cylinders and compressive strength testing and everything else, and slump test, and that was where MassDOT had to do their biggest reach, was everything you ever learned about concrete and were told was what it should be, throw that away, and this is what we're doing.
Because normally you would take your standard air test, you would do your temperature test, you would do your cylinders, you'd also do your slump. Well, with this particular concrete, because we had to achieve such a great strength in such a minimal amount of time, in order to open up the traffic for 5 a.m. on Monday morning, this concrete would flash. It would come out of the chute at about a 10 or 11 inch slump. By the time maybe 4/5 of the truck was poured, and they could only deliver it in 5 cubic yard loads, we would have about a 2 or 3 inch slump.
We threw more concrete away. Just because
of the workability issue.
Yeah.
You'd have like meatballs coming out of the chute.
Right. I according to the video, you guys the concrete was cured and achieved your design PSI by 10 p.m.
On Sunday.
Right. Was there another layer of bituminous concrete to go on top of that?
No. We opened it up to traffic as the exposed concrete deck.
Okay.
During the week.
For a week.
We would get ready. The following weekend, we'd do the membrane waterproofing. As we moved down line and did another bridge, we'd do the membrane waterproofing and the first layer of paving.
Okay.
on the successive weeks.
Okay.
And then we did the final pavement towards the end of the project.
So basically what we do, if you take a look at that board there, we'd be demoing the bridge over Route 16 on northbound on weekend 3. On weekend 2, we'd be applying the waterproof membrane on both Salem Street bridges northbound, and on weekend 1, and then that same weekend, Riverside Ave, we'd be paving.
Mm-hmm.
So just because we've put the bridge deck, we replaced the bridge deck,
Right.
we still had ancillary work on the previous 2 weekends.
I see.
Who was you said Chicago, what was that company that did the quality on the concrete?
CTL, Chicago Testing Laboratories Incorporated, I believe.
Okay. And they're the group that
They were the
figured
group,
out the concrete.
they figured the concrete out on their specifications that we asked for the design build team. They were hired by White Kiewit.
Your Monday weekly meeting, was it like a whole day meeting? I mean,
Yes.
with all those people together?
Yes.
There must be a very long section of lesson learned from every weekend.
Every week.
Exactly, yeah.
We had a lessons learned meeting. They would break out from the original big meeting to more critical path guys that were involved in the weekend. We actually had the governor sit in a couple of times because it was such a large project.
Right.
Secretary of Transportation was on site every weekend, sat in a lot of our Monday meetings, sat in a lot of our Wednesday meetings. It was nothing for anybody to show up. I mean, Victor Mendez from the federal government, the area administrator, was on site a couple times prior to the 160 people that came out.
When 160 people represented the multiple state DOTs, I mean, if you look at the video there, it looked like a whole bunch of Sherbrooke push pops because they had all the reflectorized, the lemons, the limes, and the types of vests that they had.
I mean, that's probably the best picture that kind of explains. That's the start of a concrete pour on a Saturday night and a Sunday morning. There was more people around.
Because about 3 or 4 in the morning. It was.
This stuff was just flashing on us. There was testing done. Let's see if I can get the. As you can see,
It was the funkiest mix I've ever seen.
Yeah, that's.
this was one of our temporary testing labs that came out, and we would test the concrete for all different things, air, slump, and get going. Then we dispatched the truck down onto the project, and we'd start pouring. This mix got so sensitive that the additives that we were putting to achieve our compressive strengths were flashing so much and so quick that they brought in 2 refrigerating trucks and kept them on site, and they were running the additives through the refrigerator truck to keep the temperature down to a consistent temperature that they wanted to handle it at, and then we were adding the concrete additives on site, the last additive. So we were slowing down the process to the set time, which gave us better workability conditions.
So when you say
safe concrete in the end, hopefully, right?
Again, ultimately, these are designed for 75 years of lifespan. So we're trying to achieve 75 years of quality control, quality assurance. But in the same sense, Monday morning at 5 a.m.'s coming, and Brian asked a question earlier. Most contractors, when you're coming down any kind of stretch, looks at a dollar and cents type of thing. Geez, if I spend $20,000, is there $20,000 out there for me to make? Type of thing.
Right.
Or am I just spending the $20,000 and not making anything?
Right.
There was a $7 million incentive on this project if they got the bridges completed. But there was also $7 million in disincentives.
Right.
So if they failed at any time, MassDOT could take away a portion or that whole $7 million.
Yeah.
So, like first weekend, scary. What do we do? Time frame. Well, they needed to be completed off the road and 4 lanes of traffic opened up in both directions at 5 a.m. So as MassDOT, we said, Well, if they don't hit 5 a.m., what do we need to do to try to ensure that they're really going to work hard to hit 5 a.m.? Not just a time frame.
Right.
You can only do that by hitting them in the pocketbook.
Right.
So at 5 a.m., if they didn't reach that time frame, it was a $250,000 disincentive from MassDOT.
Any
Per weekend.
Per weekend.
Per weekend.
Every 15 minutes after that is another $50,000, up to a total value of $1 million
A weekend.
a weekend.
Wow.
Wow.
Okay? So now, technically, they could have failed 7 times for $1 million, and then they never would have got the $7 million at the end for the incentive, because we would have taken it away here, you know, and then there was portions up to another $1 million if they weren't done by the last weekend of August. If you don't have the last bridge done before Memorial Day, Labor Day, then you don't get that $7 million.
Every 15 minutes, it was how much money? I'm sorry, past
50,000.
50,000.
Yeah.
I bought a new watch before the project. I went to Aruba, my Aruba shirt in February, and I said to the wife, I said, I better buy a new watch because this summer could cost somebody a lot of money. You know, so that was kind of a standard joke at the table, because what was the size of the conference table? 18 feet long.
Right.
We had seats all around it, and then we had seats on the outer perimeter all around it, and we used to always have standing room only. And just like this, everybody's looking at me, and Bob, he sat right here. It was like, don't you go anywhere, because... You know.
Did anybody ever go past the 5 a.m. deadline?
Not even close.
Not even close.
Not even close.
But the first bridge was at 10 p.m. it was done, they showed?
We had it
It was on time for the 11 o'clock newscast.
Right.
Yeah.
They had representatives, at least from Channel 5, there might have been one other that were on site interviewing some people. And it was like, oh my God, they actually did it. And, well, I said, well, hold everything because we still have 9 more weekends to go.
Right. So that's impressive.
You mentioned there
itself.
was a lot of concrete that didn't meet the criteria and get thrown away.
Yep.
Who ate those?
Contractor. It's
Okay.
part of his quality control.
Okay.
It's just like, that's our normal specification on any job. If we get an inferior concrete, we discard it. That falls on the contractor / subcontractor who is the supplier.
Was there any portion of the bridge repair was questionable on
No.
the concrete mix?
No.
Okay.
No, we by Monday morning we were 10, 11, 12,000 psi on our closure pour concrete. You know, less than 24 hours. You know, it was crazy.
Yeah. Wow. And when you talked about it flashing, is that just the act of it hardening up? When you say that?
Yeah. It's all the additives, the admixtures, and the accelerants. Plenty of accelerants, and the Delvo puck right at the that was the last thing that went into the revolving drum prior to discharge.
Wow.
So it was.
That's pretty impressive.
Yeah.
So when, you know, Carmageddon was going on at the same time out in California on the 405 freeway. They were taking down one bridge, and they publicized it out in California. Caltrain really publicized this whole thing. We're going to take down this bridge on the 405. I'm going to do it in one weekend. And Bobby and I are sitting out there going, what's so impressive about California? They're only taking it down. We're taking 2 down and putting 2 back up in the same weekend. You know,
Yeah.
So, did we beat Caltrain? Yes, absolutely. They had their own problems out there with traffic. We do too, because we're right next to the city here. But it's quite impressive to take 2 down and put 2 up in the same weekend.
I'm hoping the future projects are not fast 14s. I hope they're like, you know, fast 4. Yeah, something a little.
There'll be more and more bundling as you see. I would think as we evolved into this technology and this procedure of doing business.
Do you feel like that throughout the process from Bridge 1 to the end, do you think the process was streamlined due to your lessons learned?
Absolutely.
It got better and better and better?
It got better by week 3.
Yeah.
Great.
The first couple weeks, carpenters that were doing the forming underneath were waiting for the steel erectors to get done. You know, they were probably there 2 and 3 hours too early type of thing, because we had no timeline. We had timelines on whiteboards throughout the office.
Yeah.
You know, we think it's going to go from here to here. But If we get done early, we need to cut, so by week 3, with the lessons learned, the White Kiwi team got to downsize their labor force on more of a critical path. Okay, you don't really need to be in at 2 a.m.
Right.
Need to be in at 12 midnight. That way, or don't even come at 2, come at 4, because we're not going to be ready until 4 o'clock for you. So it helped them with their first couple weekends. The labor force was pretty much stumbling on top of each other.
Yeah.
We had too many people there, but they didn't know.
Right.
They didn't know when things were going to get.
Yeah.
Well, it's all part of that, the learning
lessons
curve,
learned
too, so it's
was huge from living it.
Yeah.
Monday morning, sit there and everybody in that room lived last weekend.
Right.
Where do we go from there? What did you see? And they brought a lot of their project managing staff in from other projects just to oversee the weekends, that type of thing. Staff-wise, where do I need to accelerate people and get people, but where do I need to take them away? Where do I need to put them? So they had their own project management staff in here looking at that. And it worked on our end too, because we were, okay, when do I need, certain type of workforce? So I need to have, obviously during the concrete pour, I had 2 teams of 4 just doing sampling. But I have stuff going on in the next bridge, and the next bridge, the next bridge. I had to bring other guys in to do all of that work. Yeah. So our own weekly scheduling for MassDOT people started slow and just kept growing. And then we needed to know where people were at certain times, and the lessons learned were incredible.
So how did a typical project weekend schedule get developed, and what type of software and methods you guys use to combine and manage all the subcontractors' activities together?
Well, the contractor was responsible for managing all subcontractors. Right. What we did with the 55-hour schedule, as well as the 10 weekend schedule, was we threw it on whiteboards. It was an old classroom. We put whiteboards up, and we actually laid out everything as far as what's going to happen, the activities within weekend 1. Those were on one section, and then you had weekend 2, weekend 3, weekend 4. Plus, there's also outside elements too. We also had concerts at the Garden. The Bruins were in the Stanley Cup playoffs at the time. Also, concerts down in Foxborough, which might impact traffic.
The whiteboard sitting there, because you can. The contractor would give us a 55-hour schedule. But his 55-hour schedule was on the workforce of the actual bridge work.
Right.
Our 55-hour schedule had traffic management involved. It had, critical path things. If certain things weren't hit at certain times, what am I going to do? Because let's face it, weekend 1, if I don't hit 5 a.m., my traffic management thoughts are going to be, where am I putting 200,000 cars? How am I getting them around? What's open? What city streets are open? What city streets are closed? What am I going to do to the Fellsway? What am I going to do to Route 28? So, we had traffic management involved. We had outside sources involved. With, high winds. These cranes shut down over 12 miles an hour. If I lose 2 or 3 hours for high winds, we called it the war room in the school, and it was set up with just people monitoring the weather, monitoring traffic, telling us, we were all on walkie-talkies, you got an accident over here, traffic's gonna get picked up over here, and that all fell back on him and I as the project managers of the job. Yeah. We had some great people from our Boston traffic section, Neil Boudreau, who was our traffic engineer, to John Gregg, who is our district traffic engineer, that worked day and night with us, and we were in communication with us constantly. Then, like I said, the state police were down the street. Yeah. All those critical paths came into play, and there was contingencies. I think there was 40-something contingencies. What do you do if this happens? That we gave to the contractor prior to ever working out here. You need to give us an answer to the contingency. What are you going to do if this happens? Yeah. The concrete's not curing. What do you do? Well, obviously it's going to push everything off. But, there was plates. What if you get to a point you can't get the concrete pour? The plant breaks down. So there was steel plates designed to go in between the concrete bolted to the bottom so we could run traffic over it. They had 42 questions, high winds were one.
Major accident within the HOV barrier system. We brought in a tow trucking company stationed at 2 locations just in case there was an accident.
Which we had. You have the bumper accidents, but when you only have 2 lanes cordoned off with barrier, you got nowhere to go.
Without any breakdown lane either.
So you got to bring them down from the top, down to wherever, back in, hook them, pull them.
Yeah.
Do the paperwork off-site, get the traffic back open. All those contingencies were thought of before we ever got out there. We actually used one of the contingencies. One of the contingency was the movable barrier machines. We had 2 of them. What happens if one breaks down? What do you do? Well, obviously, you can still perform the work with a time delay of about an hour. It could go up to the end.
Yeah.
Unload its first line of barrier, back all the way back down, hook back on, and then move it to second lane. But there was an hour to about an hour and a half involved in that contingency. What else can we do? Well, we had one fail. We had the lead barrier truck fail one night.
Right.
We had a tractor trailer tow truck on site. He backed into it and pulled it. He moved the barrier at the same time. The tractor trailer became his power.
Wow.
The rest of his stuff is just run on wheels.
Yeah.
So it didn't matter. The barrier moved out. He stayed online.
Wow.
We got it. They had 55 hours to fix the barrier moving machine before they needed to put it back into play.
Right.
So they got right on it with their mechanics.
Basically, within the machine, the barrier is just running on tracks.
And that all
That way it
fell
can
on
shift
them.
from one lane to the other.
It was a subcontractor, Cody, out of Lawrence, came down, gave him a proposal. I'm going to give 2 trucks. The big one's going to get stashed down the street if you need it. Driver can go over and get that.
Right.
So.
Those risk management stuff, was that all housed like in a document